This is Rosen 13.2 on finite state machines with outputs. Here we discuss the more formal definition of an FSM. And a finite state machine is a six-tuple. It takes six things to define it. And those items needed to define a finite state machine are the set S of all the possible states, an input alphabet, and an output alphabet. And then we need a function that manages the state transitions. And then we need a function that provides the output given the state and the input pair. And then we need to designate an initial state, and usually that state will be called S sub 0. All right, and then if we want to describe a finite state machine with output, we could do it with a state table. It has two portions. One portion represents the state transition function, and the other portion represents the output function. Here's an example of a state table of a finite state machine that has four states. It has bit 0, 1 input, and it doesn't designate it, but generally the starting state is S0. All right, so that's a designation of a finite state machine. Another way to do it is with a state diagram or a directed graph that has labeled edges. And then the states are represented by the vertices or the circles. And here is the state diagram representation of the same finite state machine on the table on the left. Our starting state is always designated, and then you can see that we'll have, if we're in state 0 and a 0 comes in, we go to state 1, 0 comes in and a 1 gets put out. So here we are in state 0, a 0 comes in, a 1 comes out, and we go to state 1. So for, in this case, the input is on the left and the output is on the right in the edge label. Okay. And let's take a look at an example. Oh, here we have the mention that S is the set of states. There's four of them. Input alphabet and output alphabet are our bits, 0, 1. Okay, so let's take a look at a type of finite state machine called the unit delay machine. And here we want to create a machine that produces the same output that has come in, but it has been padded by an initial string of zeros. In our case, we're going to only delay it by one position, so we'll have a 1 in front of it. So how can I produce a machine that delays the string by one unit of time or one transition? So if I have an input of x1, x2, and so forth, the output looks like 0, x1, x2, and so forth. All right, so I've got to have my input alphabet as 0 or 1. My starting state will be S0, so I know that the first thing that comes out will be a 0. So no matter what comes in, a 0 is going to come out from my starting state. And then I have to have states that remember. So state 1 is the state the machine will go to if a 1 has come in. And then whenever the machine leaves that state, it will produce a 1 as an output. And then I need a state that remembers that a 0 had come in, and it will always produce a 0 for its output, no matter what the input is. And here's the state diagram version of this. So my starting state, if a 1 comes in, a 0 comes out. If a 0 comes in, a 0 also comes out. And if a 0 comes in, I go to state 2, which remembers a 0 had come in. So it remembers 0. And state 1 remembers that a 1 had come in. So that if a 1 comes in here, a 1 comes out, but also if a 0 comes in, a 1 comes out. And likewise for state 2, no matter what comes in, a 0 is going to be put out. So if I have an input of 1, 1, 0, 1, 0, what does the output look like? Well, the first one is going to be a 0, and I go to state 1. And the 1 comes in here, so 1 comes out. And I'm still in state 1. Now a 0 comes in, a 1 comes out, but I go to state 0. I'm in state 2. And state 2, a 1 comes in, a 0 is going to come out. I'm going to go back to state 1. And then I'm in state 1, a 0 comes in, and a 1 comes out. So you can see that I have delayed my input by 1 position with this machine. In order to remember 2 bits, I would need, I need 2 states to remember a 0 or 1 input. But if I want to remember 2 positions, now there's 4 possible inputs I need to remember 0, 0, 0, 1, 1, 0, and 1, 1. So it would take me 4 states to remember all those possible inputs. All right, and that's a finite state machine with output used to create a unit delay machine.